Hello and welcome to the Active Inference Lab. This is the Active Inference live stream. Today we are in Active Inference live stream 14.2 on January 26th, 2021. Today is going to be a great conversation, so thanks everyone who's here live and thanks everybody who's watching live and in replay. Welcome to the Active Inference Lab. The Active Inference Lab, as I share my screen, is an experiment in online team communication, learning, and practice related to active inference. You can find us on our website, at Twitter, Gmail, YouTube, or our public Keybase username and or public Keybase team and shared username. This is a recorded and an archived live stream, so please provide us with feedback so that we can improve on our work. All backgrounds and perspectives are welcome here. And as far as video etiquette for live stream goes, check out the checklist and remember to fill out the survey at the end to give us feedback. And then during the conversation, we'll mute and we'll raise our hands so we can hear from everybody. To learn more about Active Inference live streams for 2021, you can go to this rb.gy link where you'll find a spreadsheet. Today we are on January 26th, 14.2 with our second participatory group discussion on The Math is Not the Territory with author Mel Andrews. And next week, as we head into February, we'll go to a different paper. So check out this spreadsheet if you want to read the papers ahead of time and get familiarized with them. Today in Active Inference Stream 14.2, we're going to go through our introductions and warm-ups. And then we're going to walk through 14.2, again, being a follow-up on The Math is Not the Territory, Navigating the Free Energy Principle by Mel Andrews in October 2020. And we're able just to kind of chill, talk, raise some questions that come to mind as we continue. And then next week, we're going to be on a different wavelength. Always welcome to have participation. So, introductions and warm-ups. It's a nice group of 7 today. We can introduce ourselves and feel free to give any kind of introduction or check-in you'd like, and then we'll pass it to somebody who hasn't spoken. So I'm Daniel, I'm in California, and I will pass it to Ivan.
Hello, my name is Ivan. I'm from Moscow, Russia, and I pass it to Marco.
Let's go to Alex first.
Hi, everyone. I'm Alex. I'm also in Moscow, Russia, and I'm a researcher in Systems Management School, and I pass it to Steven.
Hello, I'm Stephen. I'm based in Toronto, Canada. I'm doing a practice-based PhD at Canterbury Christ Church University, and I'm going to pass it over to Cherry.
Sarah, if you want to. Otherwise, let's go to Marco.
Hi, I'm Marco, based in Holland, and I'm just an active inference enthusiast. I'll pass it to Mel.
Mel?
Hi there, I'm Mel Andrews. I'm doing a PhD in adjacent stuff at the University of Cincinnati. Is that it? Is that all of us?
Yes, cool. And then Sarah, anytime you want to jump in is chill. So today, oh yeah, go ahead, Sarah.
Hi, I'm Sarah. I'm a person interested in stuff and things. Mel's talk is awesome. Here I am.
What else can be said? So for the for the warm-up questions, we'll just dwell on them. They're just openings and just opportunities for us to raise the kinds of things we've been thinking about today. And so what is the what's something you're excited about today? And then also, what did the article or last week's discussion make you curious about? So something you're bringing exciting today, or just a question, or even if it's adjacent or it's not a quote from the paper or anything like that, like who are we that has brought us today to this conversation? Marco, and then I believe it's Stephen, but Stephen and Mel, if you could add your name on Jitsi. But Marco and then Stephen.
Yeah. Well, last week we ended the discussion with at least 3 people: Mel, me, and Alex Kiefer, on the prospect of continuing the discussion about the relation between thermodynamic entropy and information theoretic entropy. So very much excited to explore that, because I think that was very crucial parts in the paper that deserve more unpacking.
Cool, Stephen, and then anyone else?
Yeah, I'm bringing an interesting dimensionality and how that relates in to like high dimensional spaces, low dimensional spaces, and entropy. So that was something that this paper really kind of got me thinking about. I think while it seems very abstract, I think it also might have some profound practical uses.
Okay, could you also speak a little bit more directly into your microphone? But thanks for that. So yes.
I'll try and...
Yes. Yep.
Okay.
So definitely, yes, philosophy paper, abstract, general, theoretical, a lot of adjectives that we hear with philosophy, but then this is almost about the philosophy of utility and about the reality of the models that we make. So it's kind of has a hand in both of those worlds, which is what makes it an interesting thing to think about. I'm also curious about that intersection of how do we generalize and abstract correctly in order that we can make more effective action. And I'll just put up the last two questions, and anyone else is welcome to raise their hand. What is something that you liked or remembered about the paper? And then what is something that you're wondering about or would like to have resolved by the end of the paper, or by the end of the discussion today? So one thing I'll just start with is if the math, and Ivan, you can mute too, please, thank you. So if the math is not the territory, then what is our metaphor here? Like, what is the territory, or what is the math? If we're gonna go with the title of the paper, that the math isn't the territory, what is our complete spatial metaphor, if that's even helpful to walk down? But it's just, yeah, just a few thoughts. Anyone else want to raise anything?
I guess I have maybe a general question, which is for Mel, like almost like a 1 to 10, or how Mel maybe feels that FEP contributes to like epistemic unfolding, like the best possible tools to allow us to ask the most relevant questions.
Yeah, Mel?
Yeah, I think I came at this with maybe a kind of naive and outdated view of the scientific method. And I really didn't like very general, very abstract models, and I really didn't like use of metaphor, because I saw a lot of the kind of mistakes that were being made with very abstract models and with kind of analogical thinking. You get a lot of like, I think I
Okay, please do not. Yeah, thanks. Make sure that everyone's audio, let's take a few minutes before the hour begins so that we're here on time, so that everything's prepared. But thanks a lot. The audience also appreciates it. Mel, continue.
What happened?
Oh, there's just audio on a loop.
Cool. Not me.
No worries. Yes, not you.
Although I was also late. Yeah, so I tended to think of certain approaches in science as being kind of bad, because I saw a lot of mistakes that were being made with them. So a lot of kind of reification, where we start with an analogy like, oh, we've got selfish genes, or oh, we've got, borrowing models from physics into biology, and then confusing them, reifying them. But the mistakes are not the methods, right? There's a distinction between the mistakes that come along with certain methods and methods themselves. And there are mistakes that come along with everything, and with any kind of approach you're going to take in science. And especially when it comes to sort of uncharted waters, you really need to be more creative. You really need more generic models. You need to be borrowing models from one domain and importing it into the new domain. You kind of casting a net, right? So when you've got very simple systems in like classical physics and chemistry, you can kind of build up direct models without doing much analogizing, right? But when it comes to dealing with something like the human brain or an ecosystem, things, you know, or even like social structures where we're just sort of out of our depth, you need a lot more looseness. And for that reason, I think when it comes to the kind of systems that we want to understand in future science, things like the SEP are actually going to be the way to go.
Cool. Well, this whole future science, I'm sure that's something we can return to. But this was a really great point that when we're exploring or constructing a new area, we do need to borrow ideas, vocabulary, methods, etc., because otherwise what is there to be discussing or converging on? But these come with baggage, preconception, and just incompleteness, because they're not the Gödelian incompleteness, just they're metaphors. They're not total one-to-one of everything. So how do we navigate borrowing from the past, but also moving into something that has different attributes? So Stephen, then anyone else.
That's a very good point in terms of, you mentioned about this, like, does it belong to science? So we often think about, is something an engineering or applied science, or is it science? But then I suppose there's a question of, when is something useful to have in a philosophical sense, somewhere in between science and philosophy? So not completely philosophy, but maybe there is another category of foundational knowing that we kind of then use to build other things upon. So maybe there's something in that.
Yeah, it's almost like this question about whether the natural kinds are disjoint or not. And then, okay, all the stuff or all the approaches that we can take, there's science and not science. Is that a clean break? Or is there multiple kinds of non-science, even multiple kinds of science? So this is the demarcation problem. And maybe the simplest demarcation would just be the bright line in the sand. But what if the demarcation problem is a little bit more nuanced and it has islands, or it has other attributes that are not just a line across the gymnasium floor? So Mel, I'd be curious, how did you think about the demarcation problem early on in your research, or when you initiated this, and then where has that taken you on the demarcation problem? Which is, again, about what is science and what isn't science.
Yeah, unfortunately, I think the longer I spend, my background is in cognitive science. I had somewhat bio background and some psych and cog sci. So this is the first time I've been, full time a philosopher, and I find that the longer that I immerse myself in philosophy, the more Quinean I become, which is, it's sort of to my chagrin. I didn't expect to see myself go in that direction.
What is that? What does that mean, the Quinean, in this context?
Yeah, naturalism, which means no backdoor to knowledge. The only access we have to knowledge is empirical. So there's like science and there's commentary on science. And there's this, I view the relationship as between science and philosophy as being kind of intrinsically connected. They need each other. The philosophy comes up with new questions and that they don't know how to ask yet empirically, and then we figure out over time ways to go about these questions empirically, and we come up with methodologies, and then the methodologies fail. They hit a standstill, and then philosophers have to come in and say, well, look, you've kind of arbitrarily narrowed yourself at the outset. We need to start thinking a different way, right? And I think in contrast to what sort of Quine, there's a kind of popular thought that goes along with naturalism nowadays, which is just that philosophy is this kind of finite stock of questions, and as we pull the questions out of the magic hat and hand them off to the empirical sciences, we run out of questions, And so, you know, fortunately, in the near future, philosophers will run out of questions to ask because the scientists will have solved all the questions, and then, you know, then we'll be out of luck, right? Which I think is just kind of hopelessly ridiculous. It's really a really simplistic picture, and I'm, you know, fortunately for me, I don't think we'll ever be out of a job. I don't think scientists will ever be out of a job. I don't think philosophers will ever be out of a job. I think there will always be questions for as long as we persist. But I do think that ultimately I am starting to come around to the idea that there's just an empirical route to knowledge. And that means, to me, where I'm at with that right now in kind of processing that and in digesting that, is that there may not be a sharp dividing line. Like there might not be a bright line distinction between science and not science. And what I really hate about this is I really want math to be entirely conventional. I want math to be invented, not discovered, constructed. And to be a naturalist about mathematics, you have to kind of accord it more reality and naturalness than I want to. But, you know, so that's where I'm at. That's my. I might have to bite that bullet. What Stephen was saying. The two people. What you were saying about kind of like foundational things that come before science. This ties into what is being said by Inés de Polito, and what was said by Matteo Colombo and Corey Wright in a 2017 piece about first principles. So there's a piece, 2017 piece called First Principles in the Life Sciences, something and mechanism. I think it's in BJPS by Matteo Colombo and Corey Wright, about first principles and the FEP. It's about the FEP, but this first principles approach.
In the live chat, put it in there. So cool. People can check that out. Do you want to continue?
Oh, yeah. Shoot.
Or Sarah, do you want to go ahead after you've adjusted your chair? But go ahead.
Yeah, I'm pulling a wire from under my desk. Yeah, I have a question for you, Mel. I'm as a person, a new student in philosophy of science, I'm bumping, and somebody who came from physics, I'm bumping up against this like dynamic that I see between philosophers and science, where, you know, science will come up with something and then there's this kind of like ankle biter dynamic where like philosophers will be like, well, what about? Yeah, but what about? And I'm just like, I mean, I want a more positive conception of what philosophy can be. And the only one so far that I see that's really clear, and I'm a new student, so it's not like, so I'm probably missing a lot, but like, I really like Chris Fields because he's more like not afraid to be sci-fi, you know, like he's not afraid to have a speculation, which is originally what a lot of philosophers did. So I'm like, I really want advice as like a student about how you feel that dynamic can be.
Cool. We'll go Mel with a direct ask, and then Marco, then Stephen.
Yeah, Chris Fields is awesome. He gave a talk recently to our to one of our working groups, and that was fascinating. A lot of it was over my head. It's just introducing so many new concepts, but really fantastic.
And he's joining in March, early March for ActInf 17. He'll be on.
Excellent.
Yes.
What are we reading?
TBD, to be determined, but we'll find out very soon.
Fantastic.
Yes.
Awesome. Yeah, there was something I read recently. There's a long story. I don't want anyone thinking that I would just go out and read Heidegger, because I wouldn't. What happened was there's a long story about tracking down Quine's typewriter and like writing back and forth with Quine's son and finding a Heidegger scholar who had just acquired the typewriter of Martin Heidegger, who I used to correspond with as a kid. But I ended up reading some Heidegger in part of as sort of part of writing a piece up with a Heidegger scholar, and just a couple paragraphs. But there was a line about that there's this sort of and this is this is like at the time of like the Vienna Circle, at the time of sort of the positivism, right? And there was this line about logic and philosophy of science kind of like limping after the sciences and sweeping things up and cobbling things back together, like cleaning up after science in this very kind of hobbled, lame way. And it wasn't contributing anything of its own. It was sort of doing like logical reconstruction of scientific developments, but nothing that actually really, contributed to furthering the ends of science. And Heidegger was decrying that and saying that we need a generative logic, that we need to go back to the model of the relationship between philosophy and science of the time of like Plato and Aristotle, and be thinking ahead of science. And I do think I very much think that's what we need. And I think to some extent there's still very much like a live tradition in philosophy of science that is stuck in this kind of we're just describing, we're just doing the bookkeeping, right? But at the same time, there's, I think, very much a live and active tradition of philosophy of science today that is really thinking ahead of science and coming up with new questions, problematizing things in a way that that leads to real breakthroughs.
Cool. Marco, then Steve.
Thanks. Yeah, I really like the discussion so far. I would like to point to the notions of abductive inference and the exploitation complementarity to maybe approach this relation of science and philosophy. So, I mean, I also have my qualms with philosophy, like Sarah and also noted. I personally really hate the excessive, well, in my view, excessive trend to seem authoritative and absolutist and these weird fetishism of universal truths and stuff. I'm not fond of that. What I'm more fond of is it's almost, for me, it's an art, right? So it's the art of taking something, a given set of assertions or propositions, whatever, and then generating more territory to explore from that, right? So the way I see it is, under active inference, knowledge is generative, right? And so that generativity can be seen as leading to abductive inference. So it generates new hypotheses, but it can also be seen as imagination. And that level, that step of generativity is then itself rooted in what's been generated upon a direct contact with empirical reality. And so for me, it's like an intermediate kind of step. It's like a detour. You create all these hypotheses, you explore the maps you created yourself, and then you can return to the empirical grounding. And so that's kind of how I see philosophy. It's kind of a detour. And like Mel said, they're inextricably connected. Without an empirical basis, you have no grounds on which to imagine and explore and reconceive, right? But at the same time, you need a path back. Everything that's reconceptualized, explored, and imagined in these, let's say, philosophical modes of inquiry can then return to the scientific realm. So it's nice back and forth. At least that's how I see it. And like Mel said, there's no clear demarcation. I don't also do think there's a clear demarcation. It's simply, for me, the gradient of how well grounded it is in the empirical roots of these inferential processes, and how much weight does it have, where the other extreme of the spectrum would be that you generate a lot of understanding or sense or reduce the energy or uncertainty by virtue of this reflexive engagement with your knowledge. I think Ryan Smith had a paper on model expansion and elaboration. So maybe that's also a nice connection, if that makes sense.
Cool. But yes, you used the
Sorry,
term.
Marco, can you say again who that was?
Sorry?
Say again who that was that had an idea? You just right at the end.
Oh,
Ryan.
yeah, no, yeah, I think Ryan Smith has something on model expansion and stuff, but I'm not sure. But also you can also check the paper on abductive inference and curiosity and insights, which is actually the paper I co-authored with Carl in 2017. Yeah, but that's kind of what I really always like. Abductive inference. It's the coolest form of inference.
Cool. Well, yeah, inductive reasoning is when you go from the particular to the general. And then deductive is when you go from the general or the philosophical idea to the specific. And then abductive is when you go sort of laterally, like your abductor or something like that. It's off to the side. And so that's this imaginative or generative way that we're talking about as kind of threading between science with the exploit and philosophy with the explore. Are we ever going to be trapped into this dialectic? Philosophy is broadening our horizon and science is narrowing them. And then it's almost like there's this abductive sideway that we can take where there's a fruitful discussion. And so that's kind of the niche and the intersection we're reimagining. So Stephen, and then anyone else who raises their hand. Stephen, then Mel.
Yeah, I think that actually that's a very good point about abduction. And in a way, you have to say everything that we know started with abduction from a child, because it's only with time that you start to set. I often think with induction is also you've got a target and you try and narrow the gap, you know. But you've got a target. So where did the target come from? How did you know what the target was? You've also got that question then of. So I think this is these questions about how they get applied are very, very relevant to bringing in this question of philosophy. You know, are you applying it to help scientists, or are you applying the philosophy to help? You know, you decide to sit, and how am I going to sit in church, or how am I going to spiritually be in myself? So you've got this kind of. And I think this is where you're starting to see the same philosophical questions being addressed with the same framework, as opposed to it being like, okay, that's for them. You know, it's starting to break down some of the silos, I think, of how it hits the ground. And I think that's quite important.
Yeah, Mel?
Yeah, it's sort of to what Marco said, but also sort of to something you said in the beginning, which is, I guess, Dan, you said this, which is, if the map is not the territory, what is the map, right? If the map is not the territory, what is the map? And I think that there's a kind of classical position in I guess both science and philosophy of science, maybe even also the popular conception of science, which is very prevalent in modern times, which is that there are like a finite number of atoms in the universe, and you know we're picking away at psychology, and we're picking away at the social sciences, and we're picking away at biology and chemistry, and so on and so forth. But there is some fundamental level of reality, you know, whether that's atoms or you know, whether that's the quantum level or whether that's string theory or what have you. But there's some ultimate level of reality, and eventually, you know, we're going to figure out how the psychology reduces to the biology, how the social reduces to the psychology, how the biology reduces to the chemistry and physics, right? And then we'll be done. And I think that this is a very mistaken and outdated view of what reality is like, but more so what our kind of epistemic acquaintance with reality is like. I think it is, as Mark was saying, far more generative, right? Where we're instead of kind of constantly reducing the allowable frames of reference for understanding the world, we're actually constantly generating them. You know, we should be doing something like model selection, right? Some models, some theories, some accounts in the sciences do similar work to others and are not as good, and those get weeded out, right? But we're also constantly coming up with new approaches, because any frame of reference, right, any model, any theory that we take is not purely a reflection of the world out there, but will also be a reflection of our kind of epistemic aims. Will also be a reflection of what we want to get out of that way of relating to the world. And so there you can see how there's going to be, you know, a kind of infinity of possible ways of getting at the world, because they all reflect our kind of ultimately subjective aims as researchers.
Yes, very nice point about the reductionism is misguided. Just the fantasy, we're going to keep on reducing to smaller and smaller pieces. So let's think about the map. If someone says, I want a map of California, and someone goes, oh, no, that's already been solved. It's made up of dirt. You say, no, I don't want that. I want to be on a road trip, or I want to be visiting my friends. So when we reintroduce action and pragmatism and utility, the argument against reductionism is very obvious, which is, okay, it may be that as a substrate, but that's not actually how we're moving forward. And then it's interesting that there's a computer science algorithm called map reduce. Now, it's a different map in a different reduce, but it's almost like action and inference. We map, we do sense making, and then we reduce the scope. So we map and we sketch out in very broad strokes, and then we have to go into that reductionist mode to go into a little bit more detail about what is actually on the road or in the ocean ahead. But we're mapping and reducing, or acting and inferring, with an eye towards the direction that we're already moving in, not just because we're going to get to the bottom of action or the bottom of inference and then just call it a day. Like, just like you said, it's an infinite game. We're going to keep on coming up with questions and keep on coming up with measurements for the dialogue between scientists and philosophers, and ultimately just participants in the knowledge enterprise, whatever somebody's title or profession happens to be. So Marco, then anyone else.
Thanks, Daniel. That was very beautiful. It's the image evoked for me is like a directed cycles of contraction and expansion, which I believe is also very active in French. But anyways, about the question about the maths and the language and everything. So my improvised pitch is the maths, or the mathematical model of active inference, effectively describe how the terrain maps itself. So if terrain is the thing itself, or the actual reality of the brain or any ecosystem, then active inference is basically saying, well, all the constituents of this ecosystem or brain, for example, is constantly inferring each other. It's constantly engaging in mutual and reflexive inference. And all these inferences will then lead to models of each other. And effectively, they all do this kind of subjective mapping, right? But all these subjective maps over scales and levels then also need to calibrate to each other. And so, yeah, if we have to play with words, I would say the maths describe how the terrain maps itself, which I think is, you know, quite nice. Also, I very strongly echo what Mel said. I was very briefly worried that she was actually arguing for reductionism, but I should know better, of course. Yes, so if it's appreciated, I really like thinking in terms of trees. So there's a book by Julio. I forgot. Sorry, but my favorite phrase is "trees of the brain, roots of the mind." For some reason, it always stuck with me, and basically it's because there's these generative trees that lead to roots at yet another level. And so again, kind to the previous discussion. So the reductionist story is more about, you know, the classic sort of essentialism, properties and objects and kinds, which I'm not a fan of. But complementing that kind of view is processualism. And so I really, again, think that this generative perspective is in spirit with processualism. Is how do these processes actually structuralize themselves, right? How do these flows and dynamics attain some kind of regular structure. And then that regular structure will be in the form of flows and generative relations. So it's like generative scaffolds. And I think that would be an interesting angle to approach ontology as well.
Cool.
Sorry. And one more point, if I can, is also want to echo what Mel said about pluralism, right? So I think looking at active inference, in my opinion, I prefer not to talk about knowledge because then you get the baggage of correspondence, notions of truth, and I think that's distracting. If you just look at it from an active inferential perspective, actually all knowledge, the value of knowledge is going to be contextual. It's going to be contingent upon the actual agents, right? Even though we can say, oh, it's just the accuracy of the states in the world as believed or as mapped, but these states don't have to conform to some objective truth. It's more about, given the states that it has modeled, if it acts based on these states, how accurate will it be? And then there's a bit of a, I guess, a pragmatist account of truth, maybe. I don't know. But I guess what I'm saying is that activism kind of implies also for epistemology that it's about the normative contextuality, and that we really should pursue pluralism in science, which yeah.
Cool. Thanks, Marco. We'll go Dave, then Mel. So I can't hear you, Dave, but you're unmuted. So maybe try to reload, or I'm not sure what's going on there. But Mel, go ahead. Or do you hear Dave? I don't hear him. Yeah.
I don't.
Okay, so yeah, Mel, go for it. But I know that you can hear us, Dave, but we're on a live stream, so we can't figure it out at this moment. So Mel, go for it.
I just want to say something effective. I think that what I guess we're all sort of converging to describe it fits in very, very well with the kind of Bayesian view, at least the Bayesian view of science in the future. There are some kind of stodgy old Bayesian views of scientific updating of the late 20th century, mid-late 20th century that I think we've surpassed. But I think if we view scientists as kind of subjective Bayesian agents coming up with like different kind of parallel models of the world and adding evidence to these and kind of retiring models that aren't useful in a way. I think this is very much what we're describing there.
Yep, it's about these metaphors, and we're talking about understanding the relationship of science and non-science. That's the Demarcation Project. And we've heard a couple of different metaphors in this introductory section. Maybe Dave, if you want to reload and try again. But in this introductory section, we talked about one was like a spectator model with the scientists doing the work, and then there's the peanut gallery, and the philosophers are either cleaning up behind them or are confusing in their trail. And that was the following after science metaphor. And we talked about how that was inadequate because there's actually a really fruitful bidirectional generative relationship. And that reminds me a little bit of a live stream. So it's almost like in the context of science, on the live stream, the people who are on the panel are the scientists. The observable states being emitted, being viewable to the world, the empirical states are like the state of the live stream. And then we have all of these curious philosophers, whatever their title or position is, in the live chat. And they're commenting, asking questions, and by doing so, engaging in this real-time dialogue. So we actually have this instantaneous system where we can talk about how the observable states are in feedback with what people are saying at that moment. So it's sort of like, again, it's just a metaphor. It's not that it carries every single dimension of the metaphor through, but it's just really interesting that there's a discussion that can be held amongst many people in the live chat that's kind of like the philosophy literature. And then the people who are in the live stream could just not be looking at the live chat. And that would be like a scientist who just tunes out and chooses not to engage with that discourse. Or the people on the live stream might be obsessed with what is happening in the live chat, and that could actually distract them and help them or prevent them from carrying out the aims of the stream. So it's a pretty fun way that our new technological affordances and the rapidity of them are helping us understand the relationships and the bidirectional dialogue between those who have, for example, technical expertise and those who are just learning, like we've seen on these streams and in the model streams. So Dave, let's see if we can hear you. And then, yep.
How's that?
Yep, go for it. And then Sarah.
Okay. Yeah, I'm glad you mentioned a road trip. That reminds me of my puzzlement why people are talking about homeostasis rather than allostasis. It seems we got the, and this is a puzzle going back to Freud's proposal for a project for a scientific psychology. We want to get to nirvana. We want to stop everything. We want to be perfectly happy in the eternal now, but then something happens and it's horrible. That's preposterous. That's not how any organism ever acts. Organisms want to go through a series of states. We want to be tired so that we can rest, and we want to rest so we can run around and get tired and be a little hungry so that we can enjoy the food more. We want to follow trajectories. We want to take road trips. Was the notion of allostasis proven to be useless, or did it just become unpopular because homeostasis seems to fit with somebody's mathematical formalisms?
I'll give a quick response on that, and then we'll go Sarah, Marco. So homeostasis is like the first pass absolute value. You say your temperature returns to a certain number, so it's homeostatic. It's thermostatic. It's just like a thermostat. And so at the first pass, somebody who's looking at just the absolute value of temperature or of blood sugar might note that it returns to a certain point. And then in a static conception of the universe, rather than this process-driven understanding, it's like, right, if it's returning to this value of 10, then it's getting homeostatically attracted back to 10. But you're taking a look at the process and the derivatives, the rates of change, and you're like, wait, it never stops. In fact, it couldn't and it shouldn't stop. So why don't we just focus on the fact that it's doing this iterant road trip that's, yes, it's returning to 10 a bunch of times, but shouldn't we highlight the fact that it's on a circular road trip rather than just say, yeah, it's at 10? So it's really two sides of the same coin, whether one chooses to highlight the instantaneous empirical observation or highlight the process and the approach that the system is actually taking to result in those observations. So just like many other things, we're looking beyond the superficial to the generative and to the underlying models. And that's what is revealing all of these patterns across systems. So Sarah and then Marco.
I'm stuck on something math-wise, but I think you could describe it as conceptual as well. When I look at as far as I've gotten anyway with active inference and FEP, it's all predicated on Bayesianism, and Bayesianism seems to have a kind of teleos in the sense that you do priors and you go forward. But I don't know. I kind of bump up against like, well, wait a minute, but what about like, built into FEP, there's like a feedback type mechanism, but it's kind of built on a substrate that is going forward. And I find that kind of interesting. Like, I wonder about the limitations around that. And I'm not well enough versed to say anything more specific. But another little side data point, which hopefully isn't a distraction from the question, is, you see a lot now in descriptions of complexity, they'll talk about, well, you need something that's of high dimensionality. And that description is very much predicated on the methods that we use to get those dimensions. It's predicated on the math techniques. And I even when I think about this high dimensionality thing, I keep coming back to this, like, well, yeah, but you've got this like, F is a function of X or X, Y, Z, like it's not, there's no feedback in the actual heuristic. Well, no, there isn't a heuristic in the end result, or in the end, like FEP, like let's say it converges, it doesn't quite converge like Markov blankets do, or like the chain MCMC does, but I don't know, you get to something that's close by energy minimization, but in the end you get to a thing where you're like, something is a function of ... and it never goes back around. Okay, that's just, I hope that's a useful question, if anybody has any thoughts around it.
Marco, and then if anyone wants to raise their hand to speak to that.
Yeah, that was very interesting. Wait. Oh yeah. Well, Daniel already did most of it, but I also want to note that it's also related to what Sarah was talking about. So there's this issue of having too much freedom in how you characterize a system, right? That it's not really well defined how you're going to define a state space, especially when we're talking about complex set of systems that model the environment. Because then we have to not talk about simply physical observables, but more the structures that they constitute. So, for example, with homeostasis and allostasis, like Daniel said, it's two sides of the same coin, and it needs to be in reference to something else. So you can say it's homeostasis in terms of one perfect temperature, and you just try to stay there, and then add to that next to it the processes of anticipation, which then get you allostasis. But another way to also look at it is, for example, you can also say, instead of having one perfect state or value, you can also talk about viable sets. For example, the domain or boundary in which the agents will survive or remain viable. And so you can say, okay, then that is the state, being in the boundary, being in a viable set. Then it reduces to 1 point again. Which again relates to, I think, what Sarah's talking about, I think, was a lot, I think, very interesting. So about the function thing, right? So for example, you can have a Markov blanket that's enacting sort of functions, and it's not built in the loop. The loop is not built into the function, but the function enacts a process, right? It generates perturbation, activities, flows, whatever, that expresses into the environment with the expectation that it expresses itself back to them. And so that's left implicit. I'm not sure if that makes sense. Also, you said something about things moving forward, and I'm not sure what you meant about it, but it did feel like it was a very interesting angle you were pursuing. So if you could elaborate that,
I
I
mean,
would love to hear it.
it was just really simply like, it was just, you have this idea of priors. So there's a kind of a teleos. You're like going forward in the way that you minimize energy or whatever.
Oh, so, well, personally, I feel like the forward metaphor that then is the problem, right? It's not necessarily forward. It's optimizing or calibrating or tuning. But I think maybe I'm just still not understanding. But it's a constant.
Yeah, you're right. That's too sad. That wasn't the right. I agree. Yeah.
The moving forward is related to historiosity and to developmental thinking. So understanding that although there might be attributes like body temperature that are returned to, so that's the homeostasis side of the coin, in another sense, there is no state that the organism returns to. So it's about how will we understand, as you pointed, the teleos, the end. Well, there's this local end directedness as the prior is updated, but then we're almost using this short-ended teleos because we don't know the ultimate end game. And as you point out, it doesn't necessarily have to converge. It just has to be the most effective model in that ensemble, in that niche at that time. And that's who does well on that statistics test or in that, ocean ecosystem. So that's sort of this updating model. And yeah, Mel, and then I'll say something about the dimensionality.
Yeah, I think the active inference free energy principle kind of framework tends to emphasize. I don't know that this is speaking exactly to the question that you raised, Sarah, but there's a way in which it kind of looks to kind of hierarchical architecture at the exclusion of parallel architecture. We don't often talk about like the jockeying of beliefs at the same level, right? Is there any interaction between kind of like models that exist in parallel, that kind of thing? And I think that there are plenty of cognitive phenomena that get mixed that way, or in biology, right? In organismal biology, for example, we miss stuff because the FEP doesn't kind of readily accommodate that as I have come to understand it and use it. I don't think it's very good at handling that, and so that's one way in which you're sort of constraining how we conceive of kind of epistemic agents engaging with the world. And there seems to be a sort of like, I guess you could say that there seems to be a directionality to it that is maybe misleading.
That's the time hypercube FEP question with like the gradient descent and the moving forward through time. What if it's kind of ironically circular and that we're experiencing it in the downhill direction, but the hill is just there and we're moving through it experientially in a way that is prospective, and it becomes pathological and not adaptive when it's not prospective. That would be like prioritizing retrospection without an eye towards anticipation, and those systems fail to exist. So we end up having this like distilled and extracted understanding of our past, only partial aspects of it, with an action-oriented view towards an uncertain future. So that's why FEP is such an interesting framework. And as Mel just pointed out, it's not like it's a lateral alternative to how the mitochondria works or how a protein folds. It's not really a scientific idea at that level. But again, to take it to this initial claim of the paper, the claim is that the FEP can be taken to belong properly to the domain of science. So then we're talking about what is in the domain of science. If we're going to be in Science-landia, is there only one kind of model? Are there multiple kinds of models? Are those models hierarchical? Are they heterarchical? How do they depend on one another? Who is involved in producing and communicating about those models? These are some of the very interesting questions that are almost within the demarcation problem. Once you're on one side of the line or the other, there's still more questions, again, highlighting the fact that it's going to be an infinite game with researchers and philosophers. So Marco, and then anyone else.
Yeah. Apologies if not actually covered this. I couldn't hear it properly. But I just want to add that, at least in my view, the idea of telos for me is at least, I don't like it because I have an allergy for anything that reeks of essentialism. So telos kind of feels like something universalistic. It's almost absolute. Right? It's like, what is the telos of this thing, right? But that breaks down when we're talking about entities or systems that are exactly defined in terms of their context, right? So each of these systems embedded in a big mutually inferring ecosystem, they are at the mercy of their context, right? They don't see the world. They only see the larger worlds through the directly adjacent systems with which they stand in an inferential relationship with, right? So for me, the normative principle of FEP is the teleological principle. As in, like I think Dan also notes this, the telos kind of is constantly changing. But there's nothing else to say, it's not different than saying that there is a normative principle that is defined in terms of the relation of the system and its context. And so that's what I find beautiful, right? So one of my key phrases is contextuality, because what's effectively happening with these systems is they're enacting inferential context. For me, maybe a nice parallel is, because Daniel noted the live stream parallel, is a domain of discourse. So what we're constantly doing in a live stream is we're cultivating or constructing and acting upon a domain of discourse. We keep adding new elements to it, new perspective, new frames, and then domain of discourse expands. But it's the same thing for these inferential systems, these market blankets, right? They are constantly changing their domain of discourse when they reconnect with other inferential adjacencies or, let's say, interlocutors. They change their domain of discourse because that domain is defined by the adjacent systems. At least in my opinion, this is, again, a bit speculative, way from the Brown's truth, but I'm curious to hear what you think.
The patterns of discourse define the interface. So it's not just that there's the essentialist nodes that are then like bumper cars on a, in a chat room who are engaging in this thing called discourse. It's like, it's a co-construction, just like you pointed out with the relational and the contextual or the ecological teleology. The purpose is multi-scale and it's relational. And then also teleology is just one of the quadrants in the 2x2 with Aristotle's 4 whys, the Tinbergen's 4 whys. So there's the teleological cause, but also there are the other quadrants. So there's other aspects of why that we might be interested in. And at any given moment, the why that's interesting or meaningful is itself situational, but there's also a pluralism there. So it's kind of like we're weaving these similar ideas of relational thinking, pluralistic thinking, and then we're finding that we're kind of pluralistic across issues. Like, we're okay with people having different perspectives in a live stream. We want to have a plurality in the literature. But then at the same time, that's that expand cycle. And then there has to be the reduce cycle. Because if we have pluralism that leads to somebody thinking that we should capsize our ship, it's not that it's you have to do it in all possible universes. This is like simply wrong. It might be enough for someone just to say, it's not my preference. It's not my C vector that this ship get capsized. So that's not a policy I want to engage in. So it's kind of like this moderated pluralism and this pragmatically oriented dialogue with philosophy and science. Stephen, and then anyone else.
And that's this pragmatism and being able to move between scales. The idea, and it talks in the paper, about thingness, the idea of something being a thing, even if it's not a living thing. You've got that, and I'm curious that it doesn't actually quote the Markovian monism sort of tag in there as that. So I'd be curious if that was a particular choice, so it didn't get locked in by that. But this idea of dimensionality is, if the free energy principle is based on entropic change, and entropic is dimensionless to some extent. It's just a scalable eigenvector sort of I don't know what you'd even call it, quality, and then it goes into thingness, then it goes into some sort of process theory, which has to have dimensions at some point. So once you go into active inference and there has to be dynamics across things, you start to have dimensions, or maybe certainly once you have something that's nested inside something else. And I just think that's really interesting. I'd be curious what Mel's thoughts are about how the dimensionality drops in and out between thingness and, say, pure entropy, and just maybe why she didn't put in Markovian monism. Was that a choice for sort of reasons of not getting caught up in it, or does she not agree with it, or something like that?
Could you just briefly introduce what Markovian monism is, or why is it exciting or relevant to you?
Okay, so Markovian monism is the kind of overarching philosophical paradigm where the idea of something being in the world is because there is a differentiation between what's outside and what's inside, and therefore there's a sense and the nature of how that inside and outside dynamic is structured, even be it a stone, in terms of the stone stays as being a stone. So there's somehow the forces inside balance its relationship to the environment outside, and therefore there isn't this dualism of the stone and purely outside the stone as a complete separation. There's somehow a merging. So everything is, to my understanding, is monism is there's kind of an underlying kind of unifying kind of dynamic that which sort of builds on the sort of ideas of David Bohm and the kind of those sort of principles, that there's something in the background which is more implicit in our existence, if I've said it right, but that's my understanding.
Okay, it's definitely a big and deserving topic. Usually the monism would mean that there's basically one kind of thing. Dualism would be the idea that there's perhaps two kinds of things. So the one type of thing in monism, whether it's matter or whether it's mind, is being manifested differentially. These two views often converge because the monist will say, yes, but it looks like two things, or the dualist will say, yes, but they're interconvertible, or they associate with each other. So it's a little bit of a weedy area. So if there's any thoughts on that, we can happily hear that. Otherwise, let's maybe slowly walk through some of these slides and just highlight some of the very nice points of the work itself, and then just think about how that kind of springboards us into 2021 and beyond. Why not? Sound good? Yep. All right, cool. Yeah, Mel, we'll go first and then we'll continue on this.
I could respond quickly. So there's a paper a few years ago that presented one view on consciousness that Carl Friston was an author on, and I think the phrase that stuck was something about the Cartesian theater. So it was very much a kind of classical dualist account, and this more recent one, right? This is just this past year, right? The Markovian monism one. Yeah, so it's an updated view on, it's an updated take on the consciousness problem, on the mind-body problem, that Friston is also an author on. I think it's interesting. It's an interesting, they're doing interesting stuff with the formalism, with the information geometry stuff. I used to be very compelled by the problem of consciousness, by the mind-body problem. I was very, I worked with that as an undergrad. That was my, so that was a big thing for me, right? And so I was like, interested in evolution and interested in consciousness. I'm on an out phase of it. I'm taking a couple of years away from the mind-body problem before I come back to it. So I'm trying to I try to keep my blinders on and focus on one or two problems at once.
Yep, philosophy has that feature of you pull on one question and then all of a sudden you're asking, how do I know? And who am I? What are we? It's because they're all very linked up, and kind of like it could be the same with science. You make a measurement about the gazelle and then you want to know about the cell. But in philosophy, it's almost hitting you all at once, and there's less clarity about how to structure those questions. And that's actually part of what I think these conversations help clarify, because in the example of the animal, we know that there's a certain nesting or interactions between different types of biological entities, and so we can coarse grain. And that allows us to make useful decisions like about wildlife management or something like that. Again, with an end in mind and a team and a method in mind, we can do useful science. And so the question is, with the method and the team and the question, how can we do useful philosophy, and then maybe even move beyond these titles overall and just have the group working on the project with the approach. So Marco, then Mel.
I just briefly wanted to join in on that discussion on consciousness because I'm not out of it yet. I'm still obsessed by it. So I think the beauty of Markovian monism or dual aspect monism is because the most beautiful thing for me for active inference is the emphasis and the primacy of mutualism, right? That nothing is without context, nothing is seen in context, and that all their so-called identities, so-called properties, so-called telos, these are just heuristics we've accumulated over the years in ignorance of the relational nature of these systems. And so the beauty is that these relations, these tangles of relations themselves become thing-like because they facilitate or allow for instantiation of a coherent activity. I forgot what the paper is. I've been trying to find it. I probably have to dig on Twitter. But there's a very nice paper about how some neural populations that might, for example, hypothetically, are about encoding cats. This just put it very simply. And they're just constantly chaotic until they get an input that is relevant or comes from the descent data about cats. And then that chaotic, high-dimensional, noisy stuff collapses into a particular order. And I think this is also interesting for you, Stephen, because you often think about spaces. And this relates to a lot of, well, some people think it's too hyped, but the work on manifolds and computational manifolds in neuroscience. So the weird thing is you have this really, a lot of neurons and population, and they're related to a relatively challenging imperative problem. But then for some reason, when you analyze the data, you can obtain a manifold. You just say, well, the neural population is basically just traveling on this low-dimensional manifold. So that's very interesting. The interpretation of that is another topic, but since you asked about dimensionality, I wanted to add that.
Yeah,
I should go too far.
Mel?
Yeah, it's what you were saying just reminded me. I had a thought yesterday. I was trying to nail down one thing, and of course, there's this, right? You pull at one thread and everything unravels. And I see that there can be a kind of systematic way of going about it. I think philosophy is it's not so chaotic. It's right. It's using the same kinds of conceptual tools, just not with the formal rigor of mathematics. But there's still kind of a systematicity to it. So it's sort of like, you know, a mean field approximation, or solving a system of differential equations approximately, right? Where you've got, you know, these 11 moving pieces, and you're taking 10 of them, and you're either sampling over them to get an average value, or you're approximating them, and you're kind of like freezing, you know, you've got all these dynamic moving pieces, but you're freezing the values of, you know, so to do this paper, right, there's no one definition of what a model is, right? In philosophy of science, there are, you know, 50 people working on models, and they have, you know, at least 8 different, like, distinct conceptions of what a model is, and what a model is rests on what similarity is, what representation is, what analogy is, right? And then you dig into these, and there are all these different conceptions of what similarity is, and what representation is, and what analogy is, right? We don't know exactly what a theory is. We don't know exactly what the scientific method is, right? But to drill down on one thing, you've got to kind of stipulate. You've got to kind of like average over the literature and find what it is that's a kind of commonality in what we think about a model, and kind of stipulate, well, you know, no one agrees on exactly what a model is, but a model is approximately this thing. And in order to figure out, you know, what this one model is doing, we can sort of stipulate roughly what a model is. And it's quite similar, I think, to what we're doing in maths and physics, but just using language.
Yes.
Mel, I think
Yep.
you've taught me more in that, like, whatever, 3 minutes than I learned from all of my professors so far. So thanks.
Yay. That's fun stuff. I agree. That was really awesome. And again, it's like philosophy and science, we're almost converging on this approach, if not just converging on the conversation. Because when you were talking about how many definitions of models there were, I thought about how many definitions of foraging there were for insects, or definitions that go beyond insects. And then I thought about, well, when we measured it in the field, we said it has to be walking in a straight line with mandibles empty between this time of day and this time of day, and there's no single point that we would draw the line in the sand. Is it 1 meter? Is it 3 meters? It's always going to be, like you said, it's about looking at the distribution of the literature. If it's outside of the bounds of literature, you're going to have a lot of justifying to do to the reviewers. That doesn't mean it's wrong. It just means that you're going to be having to make special claims, like you're going to have to write an extra subsection in your paper to justify why you did that. But then if you use exactly what the literature did, again, whether it's right or wrong, it doesn't ask to be justified. And so people who are operating within that center of that mean field approximation, they kind of just point outside, and they don't need to do an internal justification of their choices or of their approach. And then you just said, like, you have to freeze other things. So you did the scholarship to show there was this whole section on scientific modeling, and then all you can really do is trace out the if-thens. You said, if you are feeling this way about models, then you would be consistent in thinking this. And it's not that it's better to be consistent versus have cognitive dissonance. It's just that you can do the scholarship and trace out the if-thens of thought. So it's just a fun way, because there's probably people who are hopefully listening to this and curious about the conversation, who are coming from the philosophical side or from a scientific or from an engineering background. And so it's like there are similarities across all of our experiences, like the need to iterate, the need to freeze specific subparts of a model, whether it's qualitative or quantitative, and then work with teams and with literature corpuses that aren't just giving a single resounding answer for what is a model or what is a foraging trip. So really just important nomadic ideas that we're broaching here. So it's just good to take stock of that. So Marco, and then we're going to just walk through a few of these slides. Unmute, Marco.
Yeah, I was saying you've again relieved me of a lot of stuff I wanted to say. but yeah, I also echo this. I think what we're seeing also in philosophy and science is moving away from or moving towards pluralism, and I don't think it's a problem that there's no consensus on a single notion of a model. I mean, a model is not a natural kind. It's a concept we're using because our, again, non-natural or abstract processes of inquiry necessitated the phrase model. And so a model itself is contextual or context dependent. So it's kind of a theory relatedness or context relatedness or norm relatedness, I guess. But I also like the comments of Mel of systematicity, right? So we've inevitably accumulated all these conceptual tools, and inevitably people will try to find systematicity in between them. And I'm kind of wondering, in a weird reflexive way, if active interest also can shed light or make interesting that phenomenon of what Wittgenstein said, letting the fly out of the fly bottle. We've surrounded ourselves with so many tools, bounded together with systematicity, without actual real justification. And so we're kind of trapped in that fly bottle because we haven't had any alternative. So, who knows? Active inference can fulfill Wittgenstein's dream.
So on the fly bottle, in undergrad, I worked in a fruit fly genetics lab, and the joke was you'd have the fly in the bottle, and you'd say, "There's the fly in its natural environment," because it couldn't live outside the lab; it would get selected out. So it's like, no, we're studying it in its natural environment. Now that was laboratory biologists who were just very aware of how selection works, but it's such a deep insight into like, yeah, you are always studying it in its setting, whatever it is, and then you just broached upon this contextual and relational thinking, and then also that modeling, it's not just about the object or the essence or the natural kind. Model is a verb. So it's like the dynamical and the relational approach is coming and imbuing all of the things that we're working on. So Stephen's working on performance, Mel's working on the history of thought and about the discourse that's happening at a very high level. We're all working on different attributes here, and then there's something that we can align around, like a strange attractor itself, and that's that we should probably be thinking about context, relationships, dynamicism, multi-scale models. So that's what crosses systems, and that's really the fun conversation that gets to emerge in these moments. Good. I'm glad that people got riled up by that. So let's go Stephen, then Dave, then Mel.
One thing that also comes to mind, I think that's quite pertinent, maybe in the broader context, which everyone, the universities, you see it, this interdisciplinarity, transdisciplinarity, participation, mostly it's words that the universities are getting into because they start, but it raises massive questions because how do you start to not just try and contest an idea within a field, or you need to work between fields, across fields, you need to bring in context and multiple contexts. And I think this, question about how we actually start to understand knowing and at fuzzy levels of knowing, which actually opens up potential to bring in people who are more marginalized because they have other ways of knowing and experiencing, and they are better adapted probably to survive in some very difficult conditions compared to the researcher themselves, so sort of without making the genetic comparison, but the whole ecosystem and bringing it all together. So I just wanted to bring up that question of like how all of this does relate to transdisciplinarity and the need to do that with the world in the state that it is.
Okay, chill. Dave, and then Mel, and then we're going to move through slides.
Jaak Panksepp made a comment along the lines of your fly bottle. He found he could not work with white rats, these specially bred rats, when he was researching the evolution and the socialization of emotion, because these are completely artificial creatures with no normal rat emotions. You can't do those things to a real rat that rat runners do with white rats. What he took was your regular old brown alley rats, the nasty, horrible rats that everybody's afraid of, raised them around people for a couple of generations, was really careful not to select out anything. And they just got to loving people that could play with you and come over to be tickled, and they'd giggle and have a wonderful time. And he says, these are real things. These are actual animals that survive in the wild. I could let them go and they'd go out and live. The white rats would be just wiped out overnight.
Okay, fair to say that, yes, it's not about the exterior shades in any species. Mel, on anything else you wanted to say there?
I actually forget what I was going to say.
But yes, chill. It is very interesting, and it's always the real environment, and who's adaptive and who's not, it's not something that could be speculated before the ecosystem emerges, because most species go extinct, and there's insects that had a strategy for 100 million years, and then they went extinct. And it was always situational and interesting questions, though. So we're going to pass over the abstract, and also there's about half an hour left in case people want to put any questions in the chat. So in the roadmap, I think it's a good place to pause on our road trip analogy. We can see some of these terms that we've brought up in the discussion reflected by sections in the paper. So, and by the way, if anyone has to leave, that's always chill. Mel, go ahead.
I have to leave.
Yes, thank you. I saw the time drawing near. Mel, thanks so much for participating in 14.1 and 2. It was just obviously great discussions, and apologies for bashing you after you leave. No, thanks for coming on.
Oh, please do.
Yeah, and any other future discussion, you're always welcome to contribute your perspective, so we'll hope to see you soon.
Fantastic. Thank you.
Cool. So, nice. We can all, continue to go around, but really interesting stuff. We did hear a lot of these things. Let's look at this table, and maybe are there any terms that we haven't really brought up? We've talked about, for example, Mel mentioned mean field. I can see a few things already, but maybe someone can raise their hand and pick a term that they don't see how it's fitting into the things we've already brought up, because these discussions, it's not the end all be all. It's just a couple of hours. Mel probably spent hundreds of hours writing the paper. So we're just sharing our perspective, seeing at the first pass how these ideas are associated. And then there's a paper and a literature and a research community to delve into if some connection is interesting. So if someone's like, whoa, with the connection between 6.1 and 4.3 was really exciting. So Dave, what would be something cool to go into?
Yeah, I first encountered the term free energy in economics, where it means something just dramatically different. It's a good thing in economics. But the closest that I've seen to a use with the connotation that we've been using it is as anxiety, free-floating anxiety, paralyzing terror, and I don't know what's wrong. Is that off the wall?
This is fun. It's definitely an unconventional economics interpretation of free energy, but it just shows how when using terms, it's always important that we understand where we're coming from, because in a way, that's what this paper and also several other papers have broached upon, which is there's a thermodynamic aspect to free energy. Gibbs free energy, which is like after you ignore the activation energy, so whether or not the kinetics of the reaction are such that it does go down, after the reaction has occurred, delta G, change in free energy, is like how exothermic the reaction was. It's what draws the reaction forward. And so you have a candle, it's like water in a dam, it isn't spilling over, and then the delta G is negative, so it wants to burn. And then when the activation energy occurs, it does burn. So that's the thermodynamics free energy. There's more to say there, and that is actually addressed in Mel's section on statistical and thermodynamics. The origins of this free energy term in this setting are from, again, statistical and thermodynamics, but as that became more and more integrated with information theory, what's called the epistemic turn, there became more and more of a marriage between physical interpretations of free energy and more informational or statistical and even Bayesian and computational understandings of free energy. So then we were at this point where free energy was being used pretty fluidly as a metaphor in machine learning, by analogy to those chemical reactions, but now in the statistical setting. And that set the stage for the innovations that Friston specifically made, which we can go into. But that, I hope, was a little recap. It sounds like economy drew this free energy term. And then just to close on that, you said a generalized anxiety. Yes, it's the differential between, being too anxious and having too much surprise and being too rigid and fragile, though converging to a perfect optimistic model is not a bad thing. So it's sort of a gradient descent on expected free energy, because just the reality of the situation is that we're not going to come to that perfect model really in any meaningful respect. It's just not how, but these are, there's other, little pitfalls and landmines and things. And these are all papers that are in a network, like the paper that we're going to be reading in 15 about, is the FEP realist or instrumentalist? Is it actually how things are, or is it just a scientific instrument? So those debates are being skipped over in this section, but that's a little bit how free energy got from statistics and statistical thermo to information theory. Marco?
Thanks. Just fair warning, I'm gonna be a bit speculative here, but I always like when people make nice metaphorical connections. So Dave, yeah, I would want to build upon your intuition. So like mentioned, we have thermodynamic free energy, and no matter what, these thermodynamic free energy can be used for work, right? But then we can ask, okay, is the work that's going to be done, is it going to be useful or not for the agents? And so this ongoing process, now we're just talking about thermodynamic free energy, this ongoing process of basically channeling or allocating or distributing the thermodynamic free energy in a way maximally useful for the agents is a challenge. So for example, it can try to challenge somewhere, which will evoke a certain inferential challenge, but when it fails, you get negative affect, right? So one part of you sends a challenge, the other part can't resolve it, and then you feel it. So yeah, I kind of feel like it's not that wrong, in my opinion, to see that, because anxiety is very specific. It's basically kind of like fear, but it has no targets, right? It's generalized. So you're afraid of spiders, but you have social anxiety because the whole domain of social interaction is just fraught with uncertainty, but without the availability of a specific reason why you're negatively uncertain, or uncertain in a negative way, if that makes sense.
Marco, I'm going to build on that because it was really helpful. So you mentioned how the FEP has to be deflated because it's like generalized bad. It's not the same as bad, but it's something that is being optimized, whether you think of it as minimizing or maximizing, depending on whether there's a negative sign. So it's the kind of thing that we're working on. That's the key point. And it's inference. What we saw here is that we're going to draw a physical analogy from the way that chemical reactions indubitably go downhill. The candle doesn't unburn. So we want to design governance structures, information schemes, economies that are like a candle, and they just irreversibly, according to our experience, they just play out. You don't have to specify the micro level detail, just as an analogy. So we want something that's going to go, quote, downhill in governance space. The thing is, we don't just want to simply do inference on it. So in the machine learning area, it'd be like, okay, what's the data set? Let's fit the estimator. Let's reduce free energy so that we can fit the estimator on the descriptive model. Like on a big k-means model, how many clusters are there? Then that will be like an inference model. We're actually doing free energy gradient descent on what? Policy selection. That's where control theory and cybernetics comes in, because we're not just doing descriptive analysis of parameters of large data sets. We're actually doing prospective or anticipatory policy selection in light of a deep knowledge reflected by embodied priors in a niche. So that is the action-oriented turn, where we go from, again, just pure free energy minimization to do inference via tricks and heuristics like variational Bayes. And Friston takes it to the next level by doing a few things, not the least of which are incorporating action conceptually, doing inference on policy selection, which we've seen embodied in the models where like the pi is influencing the B. So the way that the state estimate is changing through time, the way that S and the B matrix are related, is being modified by policy. So policy is what free energy is plugging into. So we're doing free energy descent on not just descriptive attributes of the world or any small or large data set, but we're doing a prospective free energy gradient descent on policy because that's about our world model and how the states of the world change. For some people, I know I was a little repetitive, but that's really some of the key history. And that helps understand how statistics and thermodynamics and Bayesian inference, which already is a big synthesis to make, how all those areas in information theory and computation and everything that's kind of quantitative that we're talking about, how did that get involved with ecological psychology, control theory, cybernetics, and then even into this deeper relational way of thinking? So that's a little bit of that, and it's an intersection that we'll, embroider over many times. But it's really a great story, and it's awesome that Mel wrote it up in a way that isn't just backroom lore, but it's something we can be like, yeah, it's in 3.1.1 in Mel's paper. So that's what's great about literature. Stephen?
Yeah, thanks, Daniel. Just got to take a breath because that was really that was quite a lot of useful information. I agree with what you're saying there, and I suppose one thing that is good to bring it back to that Gibbs free energy is, there are times when, for instance, when ice freezes, and the actual free energy is such that it acts as a force. It acts as a force so that the lower energy molecules are not necessarily purely favored, and it takes a slightly different structure, and you end up forming ice, of which it goes to a state which is not necessarily energetically favorable. So but that dynamic is still something that can happen over time with equilibrium. So you've got this ability, as you mentioned, to sort of to select policies outside of equilibrium to keep going and to work with that. But I think that what the free energy does, and what this talks about, that's a bit different to how a lot of people talk about emergence and stuff, is they normally work with these phase shifts, and this kind of like, if you put enough molecules in a box and get them to be constrained in this way, and that it will emerge, that you'll get the ice, or it emerge that the ice becomes water. And that seems to be like the prevalent way of thinking about emergence sometimes in kind of economics and some other cases. It's just the interactions under the temperature and pressure. But what this gives a way to think about how it can be innovated upon and thought about in terms of policy selections happening at multiple scales. And the challenge is, it depends which scale you go at and you're talking to try and explain it to someone, so the cell versus the organ versus the organism. But I think that that's something that this really helps to unpack, because you can't deny that this is not just emergence as you put everything together and they'll interact, and it involves some sort of sentient or some sort of way of building up, but starting from a non-intentional base. So and it's got both, which I think is really cool.
Thanks, Stephen. I want to mention 2 points. So you talked about a phase change, and so that's a reversible phase change with like melting and thawing. So it's a little bit different than the candle, the melt, thaw, resolve itself into a dew, that kind of stuff. So it's slightly different with a chemical reaction versus freezing, just from the chemical side. But you mentioned it was not favorable for the water molecule to freeze from the liquid into the solid phase. So go from freeze from liquid water into solid water. But actually, it is. It's that as the thermal energy reduces, all of a sudden it clicks into a new differentially configured arrangement. And so that's what the phase is like when you're at absolute zero. I assume most substances are solid. Like they're in whatever their ground state configuration is, which is like a close packing. It's a crystal of some kind. It's a solid. And then there's some temperature, T, where that crystal melts, where all of a sudden it's like the iron is vibrating. It's a crystal, it's 1,000 degrees, it's 2,000 degrees. I don't know what the melting temperature is. But at some point, the iron is breaking out of its crystal and goes into the liquid phase. And then there's still the interattraction of the different molecules in the liquid, even the iron. And then at some point it vaporizes when you're even hotter than that, and plasma and so on. So these phase changes are actually, they're about the temperature. And then if you want to go to that fallacy you're kind of mentioning, it's like people think that you're going to get a quote phase change by adding more into a box or by stabilizing it. But it's like, no, if you're at the wrong temperature, you're never going to get ice. you need to do an enormous amount of pressure to get solid above zero. You have to crush with like millions of pounds of pressure, but you can make water into ice at like 5 degrees Celsius. You just have to put a massive amount of pressure. And so the question is, how do you do it with zero pressure? That's by changing the temperature. And that's where this multi-scale, Yvonne in the chat, 2282 Fahrenheit for iron. Thanks for that. Super clutch. Then the second point, just quickly, and anyone else then, Sarah, is which scale? And you said the cell or the person in the society. And to me, that's making me think of Helen Longino's book on pluralism, because she discusses how the different fields like the sociology, the geneticists, the molecular biologists, they have stories about aggression and sexuality in the case of her book. And depending on which methods you're familiar with, which affordances you have at hand, which aspects of the world you're sensitized to, you're going to tell a different story. A molecular biologist is going to have a protein binding answer to, for example, a pandemic. A sociologist is going to know about some social intervention. And so there's all these different people, and it's not just that one person's worldview is like the right model and someone else's is the right one. That's kind of this question is which scale? It's not for any one person per se to say, but those are the questions that we need to gravitate around to make action that isn't unduly biased towards the molecular, towards the social, etc., but rather something that works across those levels. So really interesting stuff, Stephen. Thanks for like always highlighting how it comes back to bigger questions like that. Sarah, and then Marco.
Yeah, I mean, maybe just to throw some more monkey wrench into this, something about what you said really reminded me of the phenomena of hysteresis. And I never really thought about hysteresis this way before, but I was like, oh, Jesus. I mean, it is true, I think, that hysteresis is an expression of hysterosity, of history. And so, with FEP, I'm not sure, with active inference, maybe, but like, I often ask myself how these various, like you have an entity as, by way of your model or natural kinds or whatever it is, but, and you hook in these entities, you're kind of, weaving or whatever these entities together by way of something. And hysteresis has always been interesting to me because it's like that extra bit of dimensionality, that phase, if you want to call it, that can hook into something, one of its neighbors. And so I often think about the, let's say with FEP or active inference, like if there's only like one interface that can be used to hook to a neighbor, maybe it's phase change or whatever that moves out to an adjacency. So like how many different degrees can be used to connect as an interface to various neighboring agential type thinking. And I know that's like left field. But Daniel, if anybody can take it somewhere, you can, or Marco, I don't know.
Marco, definitely take the first swing at it or anything else you want to talk about.
Thanks, I'll do my best. So let me just grab my thoughts before I lose them. Oh yeah. Sarah, but what you just said, I'm not sure if you find it relevant, but one of my favorite papers is from Avena Königsberger and Olaf Sporns and other people about routing strategy. So I personally am very fond of the conceptual set of flows and paths and routes, right? Because policy selection can also be seen as navigating a certain policy space. So this paper, A Spectrum of Routing Strategies, effectively is tackling an interesting question of when you have a given system, how much non-local, how much information in its adjacency, in its context, does it need to incorporate, right? So as it expands, let's say its domain of discourse or its inferential context, as it expands, there will be a non-linear growth in, let's say, the dimensionality or the rank with the involved elements, as it were. And that's a cost. But at the same time, if you don't expand, maybe you're just not able to resolve a certain inferential challenge. And so this trade-off of how local and how global or how expansive you want to go for a certain inferential context is, I think, related to what you're saying, right? So how many degrees can you afford when it comes to selecting how you go about something, selecting a policy? If I answered your question, I'm not sure if it's relevant, but I linked it in the YouTube comments.
Thank you.
And the other thing, what we were talking before, thermodynamics. Oh yeah, I am still not mathematically competent enough. But for those who are, I linked also in the YouTube chat to a article by John Carlos Bayes, who is like a huge figure in mathematics at the moment.
Yep.
And he wrote something about entropic forces. And when I discovered this, it was just mind-blowing and amazing, because basically what he's doing is he's licensing talking about forces as governed by entropy. So it's basically about whether the temperature is static or whether it is either thermostatic or motion static, was it? Anyways, but when the temperature is static, then the forces are better described in terms of entropy, which I wanted to emphasize because we had this discussion a bit with Stephen's point earlier. And I often like saying to people when they don't like normative principles, there's always, at the very least, the ultimate normative principle, which is the principle of least action, e.g. physics, or the cycle of thermodynamics. There's always that. No matter what, every system has to be governed by that. So given that we won't deviate from that law, we can say the brain is governed by a principle of least action. But clearly, it also is governed by imperative to systematicity, or mutual inference, this constant co-regulation. And so the question that I wanted to explore is kind of how does that link together? How I like to politically phrase it is basically these kinds of systems are effectively cultivating nature to do the work for them. It's like, how do you transform the dynamics governed by the ultimate principle of least action? How do you nudge that into also being systematically conforming not just physics but also your inferential imperatives, if that makes sense?
So this is a very subtle and really interesting point, Marco. Thanks a lot. Let me try to trace a little of that. So you were pointing out how Bayes' work on entropy and some other aspects of information theory and the fundamentals of physics, it's almost like integrating statics and dynamics into one more unified field. And you're muted, but is that correct? Or where did that, and I'm trying to trace how this comes into the thermodynamics side, because continue though. I'd like to understand that a little better.
Yeah, I mean, honestly, I think we should have a discussion maybe later, because it's actually a brief post. I'm not sure if he has a formal paper about it.
Okay.
But in general, Bayes has a lot of interesting work about entropy in biological system. Again, way out of my element there, too deep for me. But I would really be curious to see what more formally competent people think about these terms. But the thing about entropy force is just a very simple blog post, and it's not that complicated.
Okay, we'll read it, discuss it, and maybe invite him or anyone else to be on a conversation. So we have about 10, 20, a little bit of time left. So let's think about some thoughts, questions we're taking forward with us, but then we can kind of flip through a few more ideas. Sarah, to your idea of hysteresis and historiosity, which are both two kind of like similar sounding words, but hysteresis is just the system where like when something happens, it doesn't return to exactly the same state. And historiosity is just the idea that things have a developmental history, like even if you re-elect the same person, they're older, it's a different world, etc. So then you also mentioned the connectivity of agents. And then that made me think about social agents and how the social networks have a hysteresis element to them. Like if there's a fracture, it's not like you just zip it back up like a sweater. It's like going to be something that has to be recovered. If it's recovered exactly or not exactly, it has to be recovered in a different way. So I kind of see where you're coming from with the hysteresis and the connectedness of agents. Now, where does active inference play into this? If it is related, I think there's some elements because we're using a lot of these words. So it's kind of like these networks of thinking about these topics. I'm not sure where one would take that, going from the idea that it's the networks and the relational insight that define function of the system, and then hysteresis and thermo. I'm thinking of a few things though, Marco.
Yeah, well, I mean, I would love to hear your thoughts about it. So I think that there's a bit of a tension because often the formula is described in relation to Markov change, which is explicitly about just being dependent on only the last state, right? But I think what Sarah was kind of alluding to, quite rightly so, is is when you have these not just one system, but interconnected systems, then a past state of a particular system might effectively come back with a detour, as it were. And I think that's kind of what she's pointing at. Even though you could, of course, define the Markov chain for every point, etc. On a different level, you can say that the past states, for example, that system expressed an influence into its larger context, and then later another system that received that influence responded with, again, a return signal or influence to that initial system, if that makes sense.
Yep.
Yeah, this is actually what I'm always obsessing about. And you can analogize it to complex numbers as well. Like the hysteresis adds that it pops out an extra dimension that something else can hook onto, and that's what I'm always thinking about with respect to, I don't know, FE. I'm not even well versed enough to even say FEP, but what I understand about active inference, like the model seems to just creep in a forward direction, but there's no side chains, like there's no side hooks. And so I'm always like, but how do you do, I don't know, like and it may just be my limited understanding, but I come from a place of thinking a lot about hysteresis and memristors and stuff, and I can't quite get the math to answer my question.
Could you elaborate on side hooks? I think that would help a lot.
Agree. What would a side hook look like? Not a sky hook for those Dennett fans out there.
Well, what I mean by, like, let's just say, like you have real numbers and then you have complex numbers. And I think of the complex plane as like a side hook, where you add an extra dimension, basically, where other things can interact with that number space by way of the complex side hook. But it might be a too limited paradigm for me to, like, I'm throwing out these random ideas that may or may not work together. But I don't know, it's let's say, shit, this is like totally sci-fi. Like you have memristors and but they're going in like voltage amplitude one direction, but then they have different paths as they go forward versus reversed. And so that phase, that kind of phase relationship might offer a relationship with something else that's related to phase or related to, whatever the physical dynamics might be around that. So I don't know, like when I think about active inference, like they're just like, well, what's happened in the past and what's going in the future and what are my priors? But there's nothing on the side that, sorry, it's as good as I can do. I don't know if that's helpful.
You riled everyone else up, so it's great. So we're gonna just slowly, we don't need to end exactly on the hour. If anyone is gonna leave on the hour, that's fine. Just maybe speak your piece as your closing piece, but we'll stay on a few minutes after, because yes, this is a really nice topic. So Marco, Dave, Stephen.
Yeah, thanks. I think I understand what you mean with side hooks, and I think maybe what you're bumping against is what I also find problematic. So it's good that you raised this. So the equations, the formalism for free energy and for FEP and active inference, they're standalone. They're like the most naive equations you can have, right? But the whole point is that when we apply them, we have to fill in the things that were previously naive. We have to, for example, only very recently, we're going to multi-agent systems with active inference. But that was always implicit in the research, as in from the first paper in 2009, 2010, it was already implicit because it explicitly talked about how it would be multi-scale, how it would be nested, right? It's all these different systems, all doing free energy minimization in relation to each other. And so that codependency, right, in these mutualistic relations, those are the side hooks, I believe. So for example, if I'm not abusing maths here, the side hook for complex numbers is it's imaginary until you square it, right? So it's a potentiality until a certain operation occurs. So in the same way, when a particular system expresses an influence into its context, it isn't affecting that system anymore until something happens, when it returns, right? So the fact that it's always situated in an extended environment, that a particular system is very naive about, actually, that it can't know everything exactly, that it has to kind of trust or offload certain influences to its context, is kind of that side, I would say. Does that make sense?
Yeah, it's one
Interesting.
of those things that once I look at the math, I'll keep that in mind, and it might start to. That's really helpful.
Oh, don't look at the math. Don't look at the math. That's the point. Don't look at the math. Right?
You'll hear
The
all
point is that
opinions.
the maths describe a general principle for how they are, by what they are governed. But they are governed in terms of states and relations to other systems, right? So I'm kind of confused because you've alluded to it many times before, how they're all connected to each other, right?
So
I
Marco,
think
But that's not in the maths.
oh wait, I'm just going to continue with the order. But
I think it's a little bit in the math, though. I think if I keep this is how I think or how I learn, is I keep these kinds of phrases and statements in mind, and I look for them in the math, and then it becomes clear. So I think, yeah, and and you've talked also, your metaphors are great. Like you've talked also about context and shifts in context, and you didn't say this, but my brain did this, like collapsing, or like something becomes.
Yes.
So it's really helpful to keep these things in mind as I'm battling my way through, these formalisms. So yeah.
I'm just gonna ask Daniel, because Daniel is way smarter than me. I know there's a mathematical notion relevance here because of matrices. You have a marginal, the diagonal, and then the other entries are for the conditional, conditioned situations, and that also reminded me of the side hooks. If that makes sense. Oh, you're a physicist.
we're gonna return to side hooks, but let's go with Dave, then Stephen.
Okay. Hysteresis and side hooks. The most elaborate discussion I've gone through on hysteresis is in Renee Tom and Chris Zeman on morphogenesis, structural stability, and catastrophes. In there, the hystereses refer to hidden states or relatively inaccessible states. So these amazing things like the financial collapse in 2007 and 2008, where you just absolutely fell off a cliff and none of the models said that would be possible. Or in, say, a psychotic break. The most stable guy in the community just goes totally wild. Or good things, too. A religious conversion that turns the slaver into the guy who wrote Amazing Grace. Well, now, more recently, Gerald Edelman emphasizes relatively inaccessible states a tremendous amount, both in his work on immunology and in neuroscience. The term he uses is degeneracy, which he borrows, I believe, from analysis, numerical analysis, to mean something roughly like a function whose inverse is not a function. Multiple ways of coming up with an activity which from the outside looks exactly like another activity, but it's implemented in a completely different way. And then in Professor Friston's paper that was suggested reading a couple of weeks ago on where he's talking about ascent, climbing, gradient ascent. He says it seems as though what's going on inside the Markovian blanket is it's learning about its environment, but it can't observe the environment. How can it be learning about something that it can never observe? So I don't know where to go with that, but it all sounds like it kind of would fit together and make a nice paper.
Thank you, Dave, for mentioning that, and lots of great points. Stephen? And then I'll also go with the side hook and hysteresis discussion.
Yeah, I think one thing this discussion really talks about is the relativity between what the organism in the Markov blanket, the generative model, and the niche and the environment. So the world out there can follow all the rules of physics, and it can have a lot of side branches, and it can go and behave in all these sorts of ways, and which we don't know about. Some we can track through the entropy, some we will know because the niche will hold it, i.e. my cup will still be on the table. So some of the kind of the stuff about least action has a benefit of maintaining a trace more clearly in the environment. So that there's I think this is where it's quite interesting, is how much the way it coming at it from both directions. I'm starting to see what Carl Friston meant there in some ways. Is sometimes it's about the model on the outside, and sometimes it's what's out there being shaped. And humans, we're doing a lot of that. So when we shape something out there, what is available? Because they talk about the adjacent possible a lot when they're doing work with people. So is it that maybe, you know, as an animal, you know, you can infer much more diffuse abductive kind of things if it's within your sensory range. However, it needs to be within the adjacent possible. Whereas in the niche, you can do things at distance. You know, you can fire something over the hill, and then you go around next week and you see where it landed. You know, which is kind of so. Anyway, I thought that's quite interesting. I think that really does speak to this two-way movement, and the fact that some pieces are more about, you know, it changes the name of the game for emergence for sure, beyond pure physics into this non-equilibrium. And I'll put a paper, because I found a paper that talked about non-equilibrium chemistry when I was looking, and it was interesting. It said that there's almost been no non-equilibrium chemistry until like they only started doing it in the 80s and 90s. And it's like it's all this at equilibrium type work where you go from one to the other. And then, of course, all life is a non-equilibrium. So it's kind of interesting because you've still got both going on. It's just happening in the niche.
Stephen, excellent point. Let me go on just about in reverse order. There's a few excellent things. You said long-range action through niche modification. That's stigmergy. The ant can't do long-range instant communication, but it can instantly put its abdomen on the ground, and then 3 months later, another nestmate could instantly detect it. So it's at an instant with a behavioral focus, but it's actually long-range with respect to action of that one nestmate on another. So then there was a discussion by Dave about how Friston was mentioning how does the organism learn, or how does the system learn when it can't directly infer or directly measure the states. And that's everything we've been talking about with the observables. The organism is actually getting the observables and using those to do state estimation on the hidden states of the world. And then it turns out that the observables don't have enough instantaneous information to reliably identify what you care about, which is the latent causes of the world. So you have this imaginative generative model, which includes that space of the adjacency, the adjacent possible, that's weighted by how likely it is, and a bunch of other stuff that makes it more like a candle burning than just a marble on a hill. So it's a little bit more nuanced because we're talking about something that's like a Bayesian computation, at least as the scientist uses it. And again, that distinction between, is this, quote, what's happening, realism, versus is this just an instrument that scientists are using in the world, that's going to come up next week in 15. And so that's like really interesting. All right. So the side hook. I thought if there's an idea with many sides, then maybe it has many side hooks, because like it's clearly by analogy to the complex number. So I like this idea though of jumping out a dimension. And that seemed like it was related to what Stephen said with the adjacent possible and with policy imagination. It's like if there's a wall in front of you and then you're only on the number line, you're going to hit into the wall. But then if you are logistically in a different dimension, then you can go around it, or you can figure out whatever policy it is. So policy and imagination is like popping out to a different dimension where then you can enact a policy. But if your imagination isn't connected to the manifold of reality, your action selection it's like a fantasy. It's like, if I could fly, I could just leave this building. It's like, yeah, but the E matrix is not that way, so it can't happen. So it has to be imagination with the affordances. And then also just one last point on the statistics. So the Markov chain that Marco, I believe, mentioned. So like a Markov chain with a memory of 1 would mean a statistical process that's only dependent. It only has a memory of 1. Whatever the previous state was, that is what influences it. And then it's almost like as a statistical model. So again, whether we think of this as a scientist instrumentally with a model, or the organism actually embodying this model. Let's just say that most things have the influence of 1 time scale, but then once in 100 times, it has like a range of 1,000. So there's 2 models you could make. You could have a model with a Markov chain of 1,000. So the different action sequences of like every single possible last 1,000 days. And that model is very computationally complicated, but if you had enough observations, it's unrealistic, you'd be able to fit that like to a T, versus the more simple model, which is just give me the memory of one so I can have just one bit of memory, and then I'll be surprised when the other thing happens. And so that is the compromise of the modeler of model accuracy minus model complexity, is do you make this Markov blanket like simple, like a heuristic or a bias, and then be surprised by particulars? Or do you try to fit this ridiculous particularized model for every single case, but then that loses all efficacy because then you're tied up so specifically with the very specifics of the model that you learned. That's like overfitting. So I know that's a ton of points, but those were all like really awesome comments. And I think we're getting to a lot of the stops on this little road trip, but let's just head to the last section. But anyone, if you have any final thoughts or questions, that was, yeah, basically the only other slide was this previous one with a little bit of, and then just the usual questions. But I'll just say thanks for participating and stay in communication with everyone. And then let's pull back to the roadmap or to here. And then each of the four of you, thanks so much for these like just amazing conversations. So each of you, if you would like to just take a, we'll go one last round if people want to. So whoever wants to raise their hand. Otherwise we can go to this one, I guess. So this slide was kind of starting with the physics on the bottom with a Fokker plank and a flow. So that was what Dave brought up. And the way that this conceptualizes a flow, like on a hill, you can have like two orthogonal curls, two orthogonal vectors. One is kind of curling around the hill at the same elevation. That's like what you see on a camping map, like the iso contours. And then the other one is like a ruler that's right on the hill, like straight up and down. And so, not to go too much into physics, but the ruler is like the delta G. It's like the gradient descent. Like, is the candle burning or are we in a flat spot? So that's the ruler, is like, are you skiing fast downhill or are you not skiing fast downhill? And then the iso contour is like is a steady state. That's like when you're doing a chemical reaction, there's always a forward and a backwards reaction. Now the KEQ, the equilibrium coefficient for the reaction's completion, might be 99.999%, like a candle. But actually the completion is really high because it's so exothermic. But Stephen, from chemical manufacturing, you know that reactions that are barely favorable, you're going to end up with like 52% of the product that you want and 48 that you don't want, or something like that. So that's that decomposition right here with a Helmholtz decomposition, that there's the solenoidal curl and irrotational or divergence components. So that's kind of a thermo-info connection. So when people are talking about gradient descent in machine learning, they're talking about like, just like chemicals are allegedly physically skiing up and down these slopes. Also in machine learning, you're doing informational skiing on these slopes. And then that's where you get these Bayesian statistics and thermodynamic ideas. The key insight in the integration with control theory happens here. Basically, if you're going to be maintaining that far from equilibrium steady state better than all the other models like you in the niche, then you need to have a generative model, not just of state estimation, because that's sort of like the low-hanging, not really fruit. Even if it is low-hanging or not, it's just not really fruit, because action is what the agent needs to do to stay far from equilibrium. Whereas a machine learning model on our computer, it doesn't need to behave well to survive, because it's like under not really the kind of selection pressures that we are, but we need the action element. So then this imperative to be self-evidencing as an information forager means that you get all of these cybernetic characteristics, and that you see systems that act as if they're doing the optimal experimentation given their priors reflected in the generative model in their niche. So that's where you get this sort of like forager information, optimal information gain principle, because that's what's needed to keep the action selection effective, because they're far from equilibrium steady state that has to be subsiding despite these things. That's what gets subsumed in free energy principle as discussed in Mel's paper. And then on the top are corollary process theories. So it's like, okay, whoa, I guess that would have to be true for any candles I saw out there. How did that energy get so organized? So it had to be an active candle, or it has to be part of the extended niche of us, right? There's no candles. That's like the watchmaker analogy. And then how does that happen? And these are falsifiable process theories, because theory, falsifiable, empirical, unique explanations and predictions. This is where we see the falsification happening. And so we discussed in this paper, like some of the already kind of, I guess, less in favor process theories, like the Gibbs filtering or Gibbs sampling, which is done on computers, but is not apparently tractable on biological architectures in the way that these more established, or I don't know, productive, not falsified yet. There's some good critiques of Bayesian brain in the paper in 15, as well as in the 2018 interview in Alias with Friston. But yeah. And then what else? Because the whole idea is that, like, as free energy principle gets shored up and connected laterally to a bunch of other things, there's going to be other process theories. Active inference is about some kinds of systems, but who knows? There's other ways we could think about it. And so I don't know. What does anyone think about that? Other than that, we'll head into our final section. Marco?
Yeah, I guess I can add a hopefully pleasant perturbation. So one interesting thing to raise here for this slide is it's conceivable that active inference might actually be more solid in its conceptual framework or structure than actually the formalism. For example, you could maybe, for example, not use KL divergence as a distance metric, but other distance metrics, because the KL divergence is, I think, also in itself an idealization, right? In the end, you're going to have a lot of messy stuff in real systems, such that even if you're going to model certain belief distributions, in the actual implementation, it's going to be extremely unlikely that it perfectly follows this particular conception of distance to be minimized. And so I guess I'm urging for this question of what can come out from it, okay, I personally just like to encourage people to be playfully exploring different variants of the free energy principle. Because personally, I believe conceptual model, taking it as a conceptual model, is better than as purely a formal model. But that's personal, I guess, outlier opinion.
Well, thanks for expressing your thoughts as an action suggestion. Stephen, and then Sarah.
Yeah, thanks for that description, Daniel. Actually, I'm going to go back and be able to use that as a really nice reference point for lots of information. I like this top piece, and I think, yeah, the Bayesian brain was there as this kind of integrating idea, and then they thought, well, let's have this predictive processing process. And I think Marco was saying, like, some of the assumptions then for it to go to active inference, you know, the math is there to make it solid, but we can think beyond that, because then they say active inference is really inactive inference, which goes another level. And the math, that's not a math thing. That's like, okay, so if it's inactive inference, and then does there need to be, like I say, what else is there? I'm actually quite interested in potentially been looking at some ideas of some spatial layers. Like we had that thing about projective consciousness and some other layers, like what's the layers beyond inactive that need to be there for these processes to be plausible? And who knows, that would be something that we'll talk about in a later date. But I like this slide could actually be something that could be played with in the future as a learning tool, because I think it's quite helpful. Great, thanks so much, Stephen. Sarah?
Oh, the trail might be kind of cold now, but you super had my attention on your, you had your arrow moving around, and you said, this is the place where there's like a connection between thermal energy and free energy. And I was like, where? Because I mean, math wise, because I've that's always just been this super separate world that's annoying and I can't really put it together. So I want to find where that is and then go find it in the math, the word description in this really nice slide, and then the math, and try to figure that out.
Great call. I agree. It's why one of our projects, just to sort of like talk a little bit about the lab, since everybody here is basically a participant in it, it's one of the reasons why having the ontology and the structure of knowledge for the equations is really important, because we want to be able to say this equation in this paper is where the variables in the F from this paper in this other math area, actually we're going to call it this letter, and here's this, and that's where there's a point of contact with this. And then is this one following from that one? Is that one following from this one? Those are the kinds of things that truly are in the frontier of what we can understand. And then understanding how to bring directly from these analytical mathematical phrasings to the control theoretic and the policy selection. That's a non-trivial, it's not a Velcro interface. That's a serious maneuver that involves also moving through, as pointed out, equilibrium and steady state and far from equilibrium, non-equilibrium, all these different things in this metaphor, or is it not, realm of info, thermo. So lots of exciting work to be done and traced. Good points. And then also, yeah, Stephen, just you pointed out, it's active inference. Imagine if someone said in 2010, well, active inference is simply one time step and it's XYZ. It's like, it was. And then now it's something else. We've talked about enactivism. We've talked about affective inference. Now, is the variable in affective inference equivalent to answering philosophical questions about affect? No, but neither was the variable affect in any other modeling framework, which again makes us pull back and just look at that instrumentalism versus realism debate. So just the realism would be, this is actually telling us how the world is arranged and what it's doing, versus just, this is a framework that is being, just like Mel's paper, this is one of the main points, is with respect to science, it's in the realm of science. But what is it in the realm of science? Well, it's not one of these falsifiable theories up here. It's something that's more like natural selection at that type of tier, but it's like a theory generator. And that's why, if we look at the roadmap, there's 14 sections on kinds of models, because this is like the system that this is being slotted into. Mel could have, or anyone potentially could go the other and say, no, it's not part of science, it's okay. So you can debate about where it is with respect to the demarcation problem. But since this is the paper we're in the journal club on, we're saying, given that that's the view being defended, the literature it has to be integrated in is not theology, it's not poetry, it's actually scientific modeling, philosophy of science literature. So then that will help us connect it to like, okay, but what does the variable in a linear regression mean? Is that realist versus instrumentalist interpretation? Nobody would say it's realist. It's not, there's not like a line in nature that's making one, group of plants a different shade than another group of plants. So that's sort of the process that this paper is engaged in, is interfacing better so that we can understand what kind of thing the FEP is. And there's a few exhortations like this. Is it true? What is it true of? How do we empirically know that it's true? And Mel argues that that's a category mistake. So it's like saying any other category mistake. Now think about these questions in relationship to the FEP being like that. So again, great paper. We'll just go to the closing thoughts now, but just thanks everyone for being a part of 14.2 and all the other sections, because this was really like two great discussions. I'm looking forward to, people can raise their hand if they want to make final comments, but I'm really looking forward to the discussion with the authors, Hippolito and Van S, on 15 for both weeks. And that will be interesting, and we'll confront this realism, instrumentalism discussion. And then also the .0 videos will be a dialogue. So hopefully more and more people will get involved with making the summaries of the videos and introducing them from different perspectives, different lengths. And each paper is unique in set of authors and set of people who are approaching it. So it's been really awesome to see people engaging with some of these truly long-standing and fundamental questions in a new light. And then also just co-creating with first just participation in live streams, maybe even just by watching, but then anybody who's watching live or in replay is always welcome to join or find out what we're doing in the lab. So it's just been a really good, we grew a lot during 14, and so it's good times. So any other final comments that the panel wants to make? Yeah,
I'm gonna grow some neurons now. This was awesome.
Peace. Marco, go for it.
Yeah, I just wanted to say, ever since I first joined, I can't find the survey you keep mentioning. I have no idea where the survey is, so maybe good to tell us and the viewers where to provide feedback, Daniel.
Sure. Well, the survey for live participants is in the event calendar. So it's in the calendar invite. And so, yeah, for those who are listening to the very bitter end, the dregs of the ActInf stream, basically the single source of truth is the calendar invite. It has the slides that are commentable, the paper, the video URL, and the feedback form. And then the feedback form, it'd be awesome if everybody fills it out. But then the feedback form for everyone else is just email, comment threads, YouTube comments, just leave feedback publicly or privately. We'll always respect both public and private feedback and let you know how it influenced our trajectory. So, but for live participants, we have a special structured form that we can always modify and evolve as well. So that's a little insider baseball, but always happy to talk about that because that's what it is we do. Is it not, Stephen and Sarah, on the Discord and all the decision making? Maybe it is, maybe it isn't. But it's been fun. So
thank you. No, it's great. Very good explanation, and I enjoyed today. Like I said, I've got to grow. I think I'll grow a spare brain, and then I'll fill it up and put it back in my head.
Just offsource it, put it in the papes. All right, good to talk to you all. I'm going to terminate the live stream.